which equals 75%. So we can say that of the people who buy televisions, or given that you've just purchased a television, there's a 75% chance you're happy. Now, it's not a cause and effect relationship, but it looks like the likelihood of being happy, provided you buy a TV, is a little bit higher. Now, I'm not selling you a TV, and I don't think this is necessarily true. This is just some numbers I was playing around with. So, of course, probably a temporary little happiness from this. Okay, so notice what we did here. We actually used this rule over here, this idea that the probability that you're happy, given that you buy a television, is the probability that you're happy and you buy a television, that's the 30%, divided by the probability that you buy a television. So you're looking at the total number of, or total percentage of things falling into here, and then of that percentage, what figure represents the probability that you want. So really all that's happening with regards to working in tables is you're modifying your denominator. It's not 30% out of 100%, it's now 30% out of 40%, because your total is based on being in the buying a television column. So given that a person is not happy, so we're given that a person is not happy, so where is that person in this table? Well, the not happy person is in the, we'll change colors here, not H row. So right now we're focusing on this one here. Okay, so given that you're in that row, what's the probability that you buy a TV? Okay, so maybe we want to understand, hey, if people aren't happy, will they go out and buy a TV? Well, the probability that you do buy a TV is 10%. That's the probability of, look, T and H not. T and not H, in other words. That's what cell we're in right now. So that's the this and this divided by the probability that you're in this row, which is 0.45. And in total, that comes out to, well, let's see, 0.1 divided by 0.45 gives us about 22% chance. So what does that tell us? Well, given that you're not happy, there's not a substantially higher likelihood that you're going to go buy a TV. In fact, the likelihood that somebody buys a TV is 40%. Given that you're unhappy, there's actually a lower likelihood that you're going to go out and buy a TV. Maybe you just aren't really interested in television. Maybe you want to go hiking. Anyhow, so these are sorts of ways to think about them. Given that you're in one group, so when we did probability of H given T, we took the probability that a person is happy and buys a TV, which was this guy here, and we divided it by the column total, which was out of 0.4, which was the probability simply that you buy a television. So we could answer any array of questions. Let's do one more. The probability that you don't buy a TV given that you are happy. Probability that you don't buy a TV given that you are happy. Well, that's going to be, the given is where you're looking, which is the probability of not buying a TV and being happy divided by the probability of being happy. One thing to really keep in mind here is that the probability that you don't buy a TV and that you're happy is not the same thing as the probability that you don't buy a TV already knowing that you're happy, because this condition comes first in this situation. These conditions come together. And that's always a tricky thing to understand about probability at first. With conditional probability, the condition comes first, and then you assess the likelihood of the event. In an AND statement, those two things are joint, and no one precedes the other. But in any case, that would in this case be, well, the probability that you're not going to buy a TV and you are happy is 25%, divided by the probability that you're happy, which is 0.55, and that comes out to 0.25 divided by 0.55 gives us 46%. So you probably will not buy a TV if you're